Man, estimation is a huge idea of calculus. So by the time Calc 2 is over, there's almost, geez, I can't remember, something like 9 or 10 or 11 different estimation methods you employ in trying to evaluate. First, though, let's say y estimation, okay? So imagine if you had some data. You are a real-life person, an economist or a biologist or something, and you had some real-life data. When you have data, you have a cloud, usually a data cloud, but hopefully there's a trend to it. And it's often the case that you try and put an equation to it called a mathematical model. Some kind of math equation that models what's going on in the data, whether it be a sinusoid or a line, whatever. You with me? Now, when you go to make a model, it's hard enough to make a good model that minimizes the distance. When you make a model, you're trying to make a model that minimizes the distances between the actual equation that predicts and the data points themselves. And so there's all these things going in your mind to how do I make this model and make it fit the data well. What's not in your mind is how can I make a model that also differentiates or integrates nicely. You just don't think there. I mean, it's hard enough to make the model. So the point is that you often make an equation or a model that can't be integrated. Not everything can be integrated. Everything can be differentiated, but not everything can be integrated, at least assuming it's continuous and differentiable. So my point is this. If you get a curve like that, there is no anti-derivative. Okay, I could try and integrate all day long, but there isn't. That said, I still want to find the area under that curve. Well, that's estimation methods. Rectangles are good, which when you see Riemann sum, that's rectangles, but trapezoids are better. So today you're going to do a better estimation method by trapezoids. You might then say, well, why did we even learn rectangles if trapezoids are better, right? Do you say that, or no, you don't care? You just say, just teach them the freaking trapezoids, I don't care why. Is that the idea? Okay. The idea is that rectangles are where the actual calculus comes from. The idea of a definite integral comes from rectangles. Riemann sums of rectangles, not trapezoids. So they're the jumping off point towards calculus. All right, now, trapezoids. Here it looks. When I estimate the area under the curve using trapezoids of equal subdivisions, I start by a picture. Now, when I say a picture, I don't mean a good picture. I mean a picture that helps me figure that out. So when I graph F and I say it looks like that, I don't really mean it looks like that. I have no idea what it looks like, and nor do I really care. I just want something to look at while I figure out where all my points are. So I'm just graphing it, and it probably doesn't look like that. Now, if I take that region and divide it into 4 equal subdivisions, that would be subdivisions at 3, 6, 9, and 12. Okay. Now, the idea of trapezoids is that you will, now first, please get out of the mindset of thinking trapezoids run with horizontal parallels. Trapezoids can be turned any which way. And you'll find that in these problems, the bases, which are the parallel sides, run vertically, not horizontally. So you're going to do a trapezoid there, and a trapezoid there. I wish I would have curved this more so they look like actual trapezoids, but you get the idea. So 4 trapezoids. This is the first trapezoid's base 1 and base 2, and there's the first height. You can see that this piece here at 3 is going to be base 2 of the left trapezoid, but it'll be base 1 of the right trapezoid. And then height 2 and height 3 and height 4. You follow? Okay. Well then, here goes. It's typical that because all have, in the formula, all have the divided by 2. Yeah? Furthermore, all have the same height. So let's factor out the greatest common factor of the height over 2. You with me? And I'll put that in a minute. Now, the first trapezoid, then if I remove the height and divide it by 2, then all it's left with is its base 1 and base 2. The second trapezoid would have its own base 1 plus base 2. A third trapezoid's base 1, base 2, and a last base 1 plus base 2. Now, these are steps that we're developing the idea, but we're going to probably leave these out in just a minute. We're going to consolidate this considerably once you see why. I don't want you to just throw it at you. What is the height in this case? 3. They are the horizontal x-axis differences. Base 1 is the function at 0. And base 2 of the first trapezoid is the function at 3. Next trapezoid. Bases are f at 3 and 6. The third trapezoid bases are f at 6 and 9. The last trapezoid at 12. Now you can combine a little like terms. You can see that there are 2 F3s. And so I could say 2 F at 3s and 2 F at 6s, 2 F at 9s, F at 12. Why are there 2 of all those? They share a base, that's base 1 for one trapezoid and base 2 for the other. Why are there only 1 on the outside? Yeah, because they're the endpoints, they're only part of one trapezoid. Now that's pretty common on equal subdivisions. You'll see 1s on the outside and 2s on the inside. And that is actually usually our starting step that will work from in the future.
Should it not be a hard equal sign?
Depends on if your area refers to area of trapezoids or area integral. You're right. If I'm saying that is the integral, then I should be saying it's true that. Thank you. Okay. At that point, then you would decide, all right, when I go to type this in, do I stash it into function 1, or do I just type in 2 sine e to the 0, 2 times 2 sine e to the... It's up to you, but you can work out the calculator. I would probably store it to F1, so I could just call up F1 instead of retyping it. Do you want to go through the putting it in your calculator, or do you think that's okay? Okay. All right, then. This then is the idea on equal subdivisions. You'll have a common height, you'll have a common divided by 2, and the inside is characterized by single outside bases and double inside bases. Are we cool?
Why did it switch from A to B?
A is the left edge and B is the right edge, and so B from the right edge. It's all good. Okay, it kind of depends on how many tries. All right then. Would you try this one on your own? If they don't call it f of x, then you might, so as not to lose somebody and say, hey, here's f of x. Nobody ever told me what it is. You might start by saying, let f of x be 1 over x squared plus 1 over x cubed, so as to identify what f means in your work, if they did. Yes.
Go back to the previous slide just for a second.
Sure.
Okay, so if you look at the equation, if you take out FA plus FB and get rid of FB, then you get the general trapezoid of what happens. You get like a secant line as the top of the trapezoid.
Yes.
And then if you separate it into 2 parts, then it would be how that makes sense is you're adding on what areas to the existing trapezoid.
You're adding.
If like if you're delegating something, when you take out like if you separate that operation into h over 2
Right.
times f of a plus f of b plus h over 2 times whatever is in between.
I'm with you.
Like I said, you explained the graph.
So then it would be h times like this. Is this what you're referring to?
Yeah. But then yours is the trapezoid. But we had more trapezoid conflict.
Where do you, oh, you're saying this trapezoid?
Yeah, that trapezoid and then there's the trapezoid.
What did you guys get?
Yeah, I see what you mean. So this would be a reference to this.
Yeah.
Kind of like this. It's not
Trapezoid, so I can only assume that the picture is biting me here because you would have to have, some of that would have to be negative areas to counteract that. So I guess that would imply that some of these are negative. Yeah, the picture's not in any way drawn to scale. But you're right, it would have to have some negative in there to make that true. Good point. I didn't even think about that. Over. How are we doing?
No, I always get too old. Yeah, I just did this because I don't like fingers. They're just like, don't wear that. And I wear nice.
Did you get something like 529 over 1,440? Yeah. Okay. How about the next one? Did you get a chance to do that, or give you a second to think it over? Give me a second. Okay. This is definitely one where you do test strategy. You wouldn't really do the problem. You just look for what looks right. What do you say? E. Tell me, how can you eliminate A, B, and C right away?
The height.
Yeah, the height over 2 would be 1/2 over 2, which is 1/4. So it's got to be D or E. Why E, not D?
The two.
The twos. That's